Hi Matt, so day 2 of the Measurement Group's Development Week here in Toulouse. What have you been up to today?
So today we've had a discussion about sensors and monitoring grid-connected and off-grid wind-based energy systems. And from those discussions we have been talking about the data that we would like to collect. And I've been working on a small, low-cost Datalogger, and this is a version of it. But from the discussion that we've had today and yesterday, there are some changes that I think I should include in this. So at the moment, I'm writing some more code to try and include those changes. So something I'd not thought about was the turbulence of the wind and how we can record the turbulence as a measurement, and also including a rotational sensor. So they're two things I'm going to implement. So in my code I'm using the Arduino. This is based on the Arduino bootloader and software. So I'm going to try this, and then we'll try and test it with the anemometer and the equipment we have here and see what happens.
Great, thanks Matt. Hi Clément, so what have you been doing today?
Aujourd'hui, on a travaillé sur comment on pouvait fabriquer notre Datalogger, donc essayer de faire une carte électronique avec quel logiciel et comment. Et donc après, il y a Jean-Marc qui est quelqu'un qui est dans le domaine depuis un bon moment. Il nous a montré différents logiciels et différents pour la programmation et la fabrication des cartes électroniques. Et cet après-midi, je me suis penché sur la fabrication d'un petit wattmètre, donc qui utilise un transducteur. Donc un transducteur, donc ça nous permet de convertir d'avoir une image du courant avec une tension entre 0 et 5 volts pour notre carte Arduino, et un petit transformateur de mesure donc pour avoir la tension de notre produite par notre onduleur. Et voilà.
Merci beaucoup.
It's okay.
So Aurélie, what have you been doing today?
Donc moi je travaille sur un projet pour les écoles, pour faire des petites éoliennes dans les écoles. Donc là on est en train de travailler sur des pales qu'on pourrait faire en 3D, qui seraient faites en classe de techno. Donc là on a un petit peu la visualisation 3D, et il y a une imprimante 3D là-bas que Gilou a réalisée. Donc voilà, on pourra envoyer les plans en open source dans les écoles pour que ça puisse être réalisé directement en classe.
Merci beaucoup. So Yassine and Jonathan, what have you been doing down here? What is this contraption?
Yeah, so we used an old motor from a washing machine, like you can see here.
It's a universal motor,
Yeah.
and with plenty of cables we didn't know what to do with, so we just figured out how it works.
Yeah, we figured out how to connect this, that it works. And here we have a controller from an old lamp.
It's a triac variator.
Yes. And we connected it up to the motor. So now you can control the speed of the motor by turning this up. Here you can adjust the speed the motor is turning.
Because we will use this to calibrate some anemometers.
Mm-hmm.
So we needed a motor with a variable speed so that we can calibrate our anemometers all the way from 6 to 12 meters per second.
And how are you going to use a motor to calibrate an anemometer?
It's like the anemometer will be on the far end of a rotating blade.
Okay.
So we will make it turn, and we will measure the RPM, and then we will have the speed of the anemometer so that we can calibrate
It's
it.
actually gonna fix on here.
Yeah.
And with the anemometer on the outside, and it's turning.
Yeah. And on the other side, some coil and magnet to measure the speed, the rotating speed. That's all.
Fantastic. Thanks, guys.